Okay, gang. Well, we're beginning this chapter section on continuity in behavior and limits. And of course, it's all involving looking at how to analyze graphs. I can't say that these are necessarily the most important things we do, but we keep coming in and out of these concepts of continuity in behavior. And it'll mention limits. Now, limits really is more of a calculus application activity. Um, we don't want to beat ourselves up with limits. It's really in a higher level course, but it is a good idea to just take a look at it. But again, like I say, as we continue through the course, we'll occasionally be looking at the concepts of continuity in behavior as well as limits. So let's get started kind of here with an introduction on these three aspects of analyzing graphs. Okay, so let's talk about continuity, and let's just go from a real brief, simple definition of what continuity is. So if I have a graph, let's say I've got a graph, and I am able to draw or trace this graph. Here's a graph of a quadratic, roughly, and I'm able to trace or draw that graph without lifting my pen or pencil, then that graph has continuity. That's continuity. So here's another example. This is more representative of what we would look at as a cubic function. And as you could see, I can trace along this graph without having to lift my pen. And therefore, that gives me an indication that this is continuous. So if there is continuity, then obviously there is the opportunity for discontinuity. And we'll in the next slide, we'll look a little bit closer at discontinuity, but let me just give a couple of examples here. Let's say, again, I've got a graph, and this might be representative of something that might be a reciprocal function, where we see in the graph going like this, and then down here in the third quadrant, it's going like this. And obviously, I had to lift my pen to graph this as I went from this portion of the graph over to this portion of the graph. That would be discontinuity. And maybe another example of discontinuity might be something like a piecewise function, maybe where I've got a graph that is headed this direction like this, and then up here it's going this way. Well, then obviously I had to lift my pen or my pencil to graph that function, and therefore that would be an example of discontinuity. Okay, so now what in behavior? So what in behavior is concerning itself with is which direction is the graph headed. Let's say I've got a graph here. We'll draw a quadratic function. It looks roughly like this, and the graph is headed off in this direction. And so I would say then here as x, if we were looking at x and it's moving towards negative infinity, it's heading in the negative direction of the graph, or the x-axis, we can then see that our in behavior over here is headed into positive infinity. It's going into positive infinity. And then also over here on the x-axis in this direction, as x is headed towards positive infinity, we see that y, the function of the graph, y, is also headed into positive infinity. Let's just take a quick look at maybe another example here. Let's say we've got something that we'll be looking at as a cubic function. It's looking something like this. Okay, and so in this instance, as x is headed towards negative infinity, we see that y, or the function value, is also headed into negative infinity. And then over here, as x is headed into positive infinity, we can see that our end behavior here, where the graph is headed, is in positive infinity. It's kind of a general direction, a general explanation of end behavior. Okay, and like I said in the introduction, I don't want us to get bogged down in limits at this point in the game. We are going to take a look at them, but again, I don't want us to get bogged down, stressed out over it, because really limits are more of a calculus application maybe than so in pre-calculus. But we keep taking a peek at it every now and then as we'll continue through. But here we're looking at the limit as it pertains to continuity. And you see up here at the top that we've got a kind of a definition or an explanation, if you will, that as the function f of x, for it to be continuous at a given point, and that's what it's really pointing to, at a given point, if x is equal to a certain value, then the function itself, as it is approaching that point from both the left and the right side, then there is a unique value of y as we are approaching this given x value, and that is called a limit. Now down below this, I think, I forget which page this is on in your book, page 24, I think, page 24. You see this little key concept block here, and this is just kind of graphically showing the same thing. So here we have a value of x, which they like to refer to as c, x equals c, or f of c, and that f of c is going to give us a unique value, or a unique y value, L. And for continuity, as we're looking at this limit, as as we are moving closer and closer to this value of x at c, whatever that may happen to be, and whatever that's given, that we're getting closer and closer to this, also to this value of y, or f of x over here, represented by this L. And at the same time, as we are moving towards from the right, as we get closer and closer to this value of c, x equaling c, or a given value, that it is also getting us closer and closer to what this y value is. And then here you see the symbols of how we express that limit. And basically what this is saying is the limit, as x is getting closer to c, that f of x is equal to L. And so here it tells us that the limit of f of x as x approaches c is L. That would indicate that we've got continuity if that is true. Okay, so now let's just take a quick look about limits as it pertains to end behavior. And again, I don't want us to get bogged down here, but just to kind of get a glimpse of it. When we're talking about limits and end behavior, we're concerned about what's happening on either end of the graph. And so you can see here that we'll be looking at the left end. What's happening is we're on the left end of the graph, as x is approaching negative infinity, what would be the limit? And also on the right end of the graph. So we're establishing limits from both the left and the right side. So let's look here at this graph here. This is some form of cubic function. But here we see that as x is approaching negative infinity, as x is headed off towards negative infinity, we can see that f of x, or the y values, are headed off into positive infinity territory. So this is an example here. We're looking at this again. This is the left end. Looking at the left end of the graph right here. As x is headed off into negative infinity, the limit is that, or f of x or y is going off into positive infinity. And then over here on the right end, as we see that x is headed into going more and more into a positive direction. In this particular example, we can see here that that f of x is actually getting more and more negative. It's headed more and more into towards negative infinity. Now, that's just an example for this particular graph that we're looking here, but we'll look at left end behavior and right end behavior. What is the graph actually doing? Is this headed to the left or headed to the right?